I'll now consider power equations. These are things that can be written in the form x to the n equal to a. And how we solve this is going to depend on what n is. If n is odd, then we can just say that x is the nth root of a. We can take the root of both sides. However, if n is even, then we take plus or minus the nth root of a. And so this is the distinction, and this comes from the fact that a negative number squared is still positive. A negative number to the fourth is still positive. In general, raising a negative number to an even power results in it being positive. However, raising a number to an odd power keeps the sign that it had originally. So this is why we have to consider two cases for the even, the plus and minus. So let's look at a few examples. X to the fourth equal to 16. Since 4 is even, we need to do plus or minus. So I have x equal to plus or minus the fourth root of 16, which is 2. So plus or minus 2. And you can double check that. 2 to the fourth is 16. And in addition, negative 2 to the fourth is also 16. For x to the fifth equal to 32, 5 is odd, so I no longer have to worry about the plus or minus. Instead, I just have x is the fifth root of 32, which is 2. And once again, you can double check this by sticking it into the original equation. 2 to the fifth is in fact 32. What if we have x to the fifth equal to negative 32? 5 is still odd, so we can just take the fifth root. And the fifth root of negative 32 is negative 2. Once again, you can double check. Negative 2 to the fifth is in fact negative 32. What about x to the fourth equal to negative 16? Well, 4 is even, so I need to take plus or minus the fourth root of negative 16. However, this thing doesn't exist. So this has no solution. We can't take an even root of a negative number. Negative 2 to the fourth would be positive 16, not negative 16. So now that we've looked at some basic examples, let's look at some slightly more complicated ones. My first one, x squared minus 7 equal to 0. So this is no longer quite in the right form, but we can put it there. So the first step would be to add 7 to both sides. That gets me x squared equal to 7. Now, since 2 is even, I can take plus or minus the square root of both sides and get that x is the square root of 7 or negative square root of 7. Another one, x minus 3 squared equal to 6. I can take the square root of both sides, and since 2 is even, I need to do plus or minus the square root of 6. And then I can take the additional step of adding 3 to both sides. That gives me x is 3 plus or minus the square root of 6. So this means I technically have two answers. 3 plus the square root of 6, 3 minus the square root of 6. The next one, 81x to the fourth equal to 16. Well, we can start by dividing both sides by 81. That gives me x to the fourth equal to 16 over 81. Since 4 is even, I'll need to take plus or minus the fourth root of both sides. And that gives me the fourth root of 16 is 2, the fourth root of 81 is 3, so I have 2/3 and negative 2/3. For our final one, I have one with fractional exponents. However, we can deal with this very, very similarly. We can start by adding 2 to both sides. That gives me 5x to the 2/3 equal to 45. Divide both sides by 5. And I get x to the 2/3 equal to 9. Well, in order to get rid of the third part, let's try raising both sides to the third power. When I raise a power to a power, I multiply, so this becomes x squared equal to, and I'm just going to leave this as 9 to the third for now. Since 2 is even, I can take plus or minus the square root of both sides. So I have plus or minus the square root of 9 cubed, which can be rewritten as the square root of 9 all cubed. We know the square root of 9 is 3. And 3 cubed is 27. So I get 27 and negative 27.